This is Sarita from Sri Venkateshwara College of Engineering, Bengaluru. In this video, I am going to discuss about some topics which is related to mathematics. The topics are introduction about integration, evaluation of double and triple integrals, evaluation of double integrals by change of order of integration, changing into polar coordinates, applications to find area and volume by double integral. So now let's get into the topic integration. Integration is a fundamental concept in calculus that involves finding the antiderivative of a function. The antiderivative, also known as the integral, represents the area under the curve of a function. Integration is used to solve a variety of problems, including finding the area of irregular shapes, calculating the displacement of an object over time, determining the average value of a function, and solving differential equations. There are different methods of integration such as power rule, substitution, integration by parts, and partial fractions. The definite integral is used to find area between 2 points on a curve, while the indefinite integral returns the general antiderivative that includes all the possible solutions to the integration problem. The notation used for integration is the integral symbol we can see here, followed by the function to be integrated and then the differential of the variable being integrated with respect to, for example, the integral of a function with f of x with respect to x is denoted as the integral of f of x dx. To solve integration problems, various techniques and rules can be applied. Some common techniques include power rule, substitution, integration by parts, partial fractions. In power rule, used for integrating functions to form in the form of x to the power of n, where n is any real number except for minus 1. For example, the integral of x to the power of 3 with respect to x is x to the power of 4 by 4. By substitution method, involving substituting a new variable for a complicated expression within the integrand, this method is useful for simplifying the integral and making it easier to evaluate. Integration by parts, based on the product rule of differentiation, it is used for integrating products of function. This method can be helpful when one part of the integrand is differentiable and the other is integratable. In partial fractions, used to break down a rational function into simpler functions, this technique is particularly used for integrating functions with complex denominators. It is important to note that integration is a reverse process of differentiation. Differentiation finds the rate of change of a function, while integration determines the cumulative effect or total area under the curve. The next topic is evaluation of double and triple integrals. In double integrals, a double integral calculates the volume under the surface over a region in the xy plane. It can be represented mathematically as double integral of f of x comma y dA, where f of x comma y is a function being integrated and dA represents the infinitesimal area element. We can see in this figure the xy plane also. The limits of integration define the region over which the integration is performed. And some common applications of double integrals include calculating areas, finding average value of a function, solving problems involving mass and centroids, calculating moments and moments of inertia. In calculating areas, by integrating a constant function over a region, the double integral can be used to determine the area of that region. Finding average values of a function by dividing the double integral of a function over the region by the area of that region, the average value of a function over that region can be found. In solving problems involving mass and centroids, double integrals can be used to find the mass of a 2D object with varying density as well as the locate its centroid. In calculating moments and moments of inertia, double integrals can be used to calculate moments and moments of inertia of an object which are important in physics. When it comes to a triple integrals, it is the extent concept of integration to a three-dimensional space. We can see in this figure the XYZ plane. They can be represented mathematically as triple integral of f of x comma y comma z dv, where f of x comma y comma z is a function being integrated and dV represents the infinitesimal volume element. And some common applications of triple integrals include calculating volumes, finding average value of a function, calculating center of mass, calculating probabilities. In calculating volumes by integrating a constant function over a region in 3D space, the triple integral can be used to determine the volume of that region. In finding average value of a function, similar to double integrals, triple integrals can be used to find the average value of a function over a 3D region. In calculating the center of mass by dividing the triple integral of a function multiplied by the position vector x, y, z by the total mass of the object, the center of mass of a 3D object can be found. In calculating probabilities, in probability theory, triple integrals can be used to calculate probabilities in the events in 3D space. Overall, both double and triple integrals have various applications in mathematics, physics, engineering, economics, and other fields where calculations involving areas, volumes, averages, moments, and probabilities are necessary. When it comes to evaluate double integral by changing the order of integration, let's consider the equation double integral of r f of x, y dA, where r is the region of integration and f of x, y is the function. To change the order of integration, we have to follow some steps. The first step is visualize the region of integration R and determine the appropriate order of integration that simplifies the integral. And write the limits of integration for the new order by considering the boundaries of the region. And set up the new integral by swapping the order of integration and adjusting the limits accordingly. For example, if the original integral is double integral of R f of x, y dA and you want to change the order of integration, you can rewrite it as double integral of r f of x, y dy dx by integrating with respect to y first and then x. Make sure that to adjust the limits of integration accordingly based on the new order. To change the double integral into polar coordinates and to follow some steps, first step is visualize the region of integration in the Cartesian plane. Express the limits of integration in polar form. This involves integrating the Cartesian coordinates x, y into polar coordinates r, theta and determine the appropriate range for the polar variables r and theta based on the region of integration. And express the functions of f of x, y in the terms of polar variables r and theta and rewrite the double integral using the polar coordinates. Double integral of r f of x, y dA is equal to double integral of df of r, theta r dr d theta. Here, D represents the transformed region of integration in polar coordinates. The next step is set up the new integral by using the appropriate limits of integration for r and theta and evaluate the new integral using the rules of integration in polar coordinates. And remember to substitute the appropriate values for r and theta when evaluating the integral. Then the last topic is a few common applications of double integration to find area and volume. For area, the formula to find area using double integration is area is equal to double integral of r1 dA. For volume, double integral of r f of x, y dA. For surface area, double integral of s, the square root of 1 plus the partial differentiation of x with respect to s whole square plus partial differentiation of with respect to y whole square of dA. For mass, double integral of r rho f of x, rho of x, y dA. For center of mass, it is x coordinate of center of mass is equal to 1 by m, the double integral of r x rho of x, y dA. For y coordinate of center of mass is equal to 1 by m double integral of r y rho of x, y dA. In these formulas, r represents the region of integration. F of x, y represents the function defining the solid or a surface. S represents the surface of the solid, and rho represents the rho of x, y represents the density of a function, and m represents the total mass. At last, double integration is widely used in mathematics, physics, engineering, and other fields to solve a variety of problems. It provides a powerful tool for analyzing and understanding two-dimensional systems and their properties. By mastering double integration, we can gain insights into the relationships between variables, calculate important quantities, and solve complex mathematical and scientific problems. So thank you. Please do share, like, and subscribe the video.